There's been a number of great and very interesting videos that have been released on the topic of AI. A lot of this is from Sequoia Capital, so a big venture capital and investment firm. And they have a few very interesting speakers, some of whom I would like to highlight. This is Andrew Ng. We've talked about his tweets before where he was talking about AI agents and sort of this next step of AI evolution. And now this is like a short presentation that he gave at the Sequoia Capital meetup talking about AI agents. So let's take a look at this, and I'll pop in every once in a while with some annoying commentary or helpful commentary, I hope.
What I'm seeing with AI agents, which I think is an exciting trend that I think everyone building in AI should pay attention to. And then also excited about all the other what's next presentations. So AI agents, today the way most of us use large language models is like this, with a non-agentic workflow where you type a prompt and generates an answer. And that's a bit like if you ask a person to write an essay on a topic, and I say, please sit down at the keyboard and just type the essay from start to finish without ever using backspace. And despite how hard this is, LLMs do it remarkably well. In contrast, with an agentic workflow, this is what it may look like. Have an AI, have an LLM, say, write an essay outline. Do you need to do any web research? If so, let's do that. Then write a first draft, and then read your own first draft and think about what parts need revision. And then revise your draft, and you go on and on. And so this workflow is much more iterative, where you may have the LLM do some thinking, and then revise this article, and then do some more thinking and iterate this through a number of times. And what not many people appreciate is this delivers remarkably better results. I've actually been really surprised myself working on these agent workflows, how well they work. I'm going to do one case study. My team analyzed some data using a coding benchmark called the Human Eval benchmark, released by OpenAI a few years ago. But this has coding problems like, given the non-empty list of integers, return the sum of all the odd elements around even positions. And it turns out the answer is a code snippet like that. So today, a lot of us will use zero-shot prompting, meaning we tell the AI, write the code and have it run on the first pass. Like, who codes like that? No human codes like that. You just type out the code and run it. Maybe you do. I can't do that. So it turns out that if you use GPT 3.5, zero-shot prompting, it gets it 48% right. GPT-4, way better, 67% right. But if you take an agentic workflow and wrap it around GPT 3.5, say, it actually does better than even GPT-4. And if you were to wrap this type of workflow around GPT-4, it also does very well. And you notice that GPT 3.5 with an agentic workflow actually outperforms GPT-4. And I think this has, and this means that this has significant consequences for I think how we all approach building applications. So agents is a term that's been tossed around a lot. There's a lot of consultant reports talk about agents, the future of AI, blah, blah, blah. I want to be a bit concrete and share with you the broad design patterns I'm seeing in agents. It's a very messy, chaotic space. Tons of research, tons of open source. There's a lot going on, but I try to categorize a bit more concretely what's going on in agents. Reflection is a tool that I think many of us should just use. It just works. Tool use, I think it's more widely appreciated, but it actually works pretty well. I think of these as pretty robust technologies. When I use them, I can almost always get them to work well. Planning and multi-agent collaboration, I think of it as more emerging. When I use them, sometimes my mind is blown for how well they work. But at least at this moment in time, I don't feel like I can always get them to work reliably. So let me walk through these 4 design patterns.
One of my favorite kind of research papers to go over on this channel was where they got this multi-agent collaboration to play Minecraft. Now, this wasn't NVIDIA's Voyager, it was a separate thing, but basically they created 4 Minecraft players, each its own, I believe it was GPT-4 at the time, and they would go out and try to complete certain goals. But before, they would all set up and kind of talk through what they need to do. So they're like, we need to build a house. How do we build a house? And the other person's like, no, guys, like we need to get some food first, right? And so as they went back and forth, their ability to reason about what they need to do improved. Then they would distribute tasks. Now, keep in mind, this is out of the box. This isn't, nobody taught it to play Minecraft. No one explained to it. I mean, there was like a prompt that kind of told it very vaguely, very in general terms what it should do, but they had to figure out everything for themselves, these 4 little AI agents playing Minecraft. And so they broke up each task that they came up with into subtasks and assigned it to each of the four players, the four AI agents. And then those AI agents went and they started executing those tasks. What was incredibly impressive and just so interesting is that they naturally, like if one would complete a task earlier than the other three, they would immediately lend a helping hand to the other three. They would say, okay, I'm done. Let me see if Bob needs some help. I should probably dig up that paper and do it again because it was absolutely like reading through it. It was so, and it wasn't one of the big papers that got a lot of attention. This was really like that video didn't do well. That paper didn't get a lot of attention, but it was just such a fascinating read because of how effective they were at going out there and completing the tasks and collaborating far better than humans. There was no complaining, there was no criticizing, there wasn't fighting over tasks or who was the boss. It was very collaborative and they would be able to course correct. So if one person had like a bad idea or there was this one AI that kept forgetting what it was doing, it was like doing the wrong thing. So the other one was like, hey, Bob, we're all chopping wood now. What are you doing? Bob was like, I'm hunting pigs. And the other three were like, no, Bob, we're chopping wood now. Go chop wood. And Bob was like, all right. Yeah, I forgot. My bad. And so they kind of like pushed each other in the right direction. There was this, I don't want to say coercion, that's a bad thing, but they were kind of like course correcting each other towards in the right direction. The only thing that was kind of bad about that paper, and they buried this like at the end after the conclusion, kind of in the appendix, was there was a time when all four bots spontaneously, they couldn't find something. They couldn't find wood or some sort of material. So one of them goes like, let's go raid this nearby village with where these peaceful villagers live. I guess they had like a library that had the needed materials. And the other four were like, yeah, you're right. We need to do that. And they just went and they raided the whole thing. They destroyed the library and took the materials that they need. So that was a little bit dark. But other than that one instance, the whole experience was very, very positive. The reason I mention is because when you think about this, think beyond narrow cases of like finishing your Excel spreadsheet or whatever. Because of of how general AI is now, this kind of idea of like general intelligence, this can be applied to anything. You can throw them in a game of Minecraft and have them work together to figure out how to do whatever, build the biggest castle and just watch the AIs in there working on that. You could create a committee that tweets for you. For example, if you're trying to build a Twitter following, right? They sit around and they're like, well, let's see what's working. And here's a tweet. Let's see how well it did. And they kind of reflect on how well they did and they keep writing better ones. Maybe one is a writer, one is a researcher, one is like trying to figure out all the hottest, latest memes and incorporate that into it. One is a artist that comes up with the art for the tweets. Now, these scenarios I'm mentioning here, we're probably not there yet. Like, I'm sure some prototypes of this they're happening right now, but we're not there where it's like completely reliable. But if you've been following along, that's the next big wave that's coming. It's going to be here soon. So as you watch this, try to think in your life, in your work or career or leisure time, whatever. Think about where could you use a team of agents that work 24 hours a day tirelessly on your behalf.
So let me walk through these 4 design patterns in the next few slides. And if some of you go back and yourself will ask your engineers to use these, I think you get a productivity boost quite quickly. So reflection, here's an example. Let's say I ask a system, please write code for me for a given task. Then we have a coder agent, just an LLM that you prompt to write code to say, def do task, write a function like that. An example of self-reflection would be if you then prompt the LLM with something like this. Here's code intended for a task, and just give it back the exact same code that it just generated. And then say, check the code carefully for correctness, sound efficiency, good construction criticism. Just write a prompt like that. It turns out the same LLM that you prompted to write the code may be able to spot problems like this, bug in line 5, maybe fix it by blah, blah, blah. And if you now take its own feedback and give it to it and re-prompt it, it may come up with a version 2 of the code that could well work better than the first version. Not guaranteed, but it works, often enough for this to be worth trying for a lot of applications. To foreshadow tool use, if you let it run unit tests, if it fails a unit test, then why did you fail the unit test? Have that conversation and maybe to figure out, fail the unit test, so you should try changing something and come.
A unit test, for those unfamiliar, is basically if you have, say, a large, complex amount of code and testing a smaller portion of it to make sure that smaller portion works. So, for example, if you have a large code that figures out if a person is eligible for something based on some number of criteria, and the first is, are they over 18, right? There's probably a block of code there that checks if they're over 18 based on their birthday, for example. So A unit test might be just testing that block of code to make sure that that block of code works. And more people are using AIs to create these little unit tests to test their own code, whether that's code that the human wrote, the engineer, or the computer itself. It can run a little unit test, see if it fails, and if it fails, potentially, using that idea of reflection to try to correct it.
By the way, for those of you that want to learn more about these technologies, I'm very excited about them. For each of the 4 sections, I have a little recommended reading section at the bottom that hopefully gives more references. And again, just to foreshadow multi-agent systems, I've described it as a single coder agent that you prompt to have it have this conversation with itself. One natural evolution of this idea is instead of a single coder agent, you can have 2 agents, where one is a coder agent and the second is a critic agent. And these could be the same base LM model, but that you prompt in different ways. Where you say, one, you're expert coder, write code. The other one say you're expert code reviewer, so review this code. And this type of workflow is actually pretty easy to implement. I think it's such a very general purpose technology. For a lot of workflows, this would give you a significant boost in the performance of LMs. The second design pattern is tool use. Many of you will already have seen LLM-based systems using tools. On the left is a screenshot from Copilot. On the right is something that I kind of extracted from GPT-4. But LLMs today, if you ask it what's the best coffee maker, can do a web search for some problems. LLMs will generate code and run code. And it turns out that there are a lot of different tools that many different people are using for analysis, for gathering information, for taking actions, for personal productivity. It turns out a lot of the early work on tool use turned out to be in the computer vision community, because before large language models, LLMs, they couldn't do anything with images. So the only option was to have the LLM generate a function call that could manipulate an image, like generate an image or do object detection or whatever. So if you actually look at literature, it's been interesting how much of the work in tool use seems like it originated from vision, because LLMs were blind to images before, GPT-4V and Lava and so on.
One interesting paper we covered on this channel is called Language Models, LLMs as Tool Makers. And in it, they found, so if you take a larger, smarter model like GPT-4, for example, and have it code up tools to use. So for example, let's say it tries to analyze a sentiment of some document based on the number of times words like sad and happy are being used, for example, right? It can actually write up code that runs and checks a particular set of text for that, or a simple calculator like the investment calculator that Andrew mentioned here. And what that paper discovered is if a GPT-4 or a higher end model codes up these little tools and calculators, whatever you call it, these scripts, these pieces of code, these tools, and gives it, let's say it spins up a smaller model, GPT 3.5 Turbo, it spins it up, it gives it those tools. Now that smaller models, interestingly enough, oftentimes will perform on the same level as GPT-4 for those narrow tasks, but will do so, better, faster and cheaper because it's a faster, cheaper model. So you can think of it as the big, smart, expensive model, creating tools for the small, cheaper models, imbuing each one with a specific tool for a specific use case. And those cheap models will often be as good as GPT-4 for that particular task. To think about that for a second, GPT-4 or the smarter models can create clones of themselves that are as good as themselves for certain tasks, but faster, cheaper. Gets a little bit weird to think about, right?
So that's tool use, and it expands what an LM can do. And then planning, for those of you that have not yet played a lot with planning algorithms, I feel like a lot of people talk about the ChatGPT moment where you're, wow, never seen anything like this. I think if you've not used planning algorithms, many people will have a kind of a AI agent. Wow, I couldn't imagine an AI agent doing this. I've run live demos where something failed and the AI agent rerouted around the failures. I've actually had quite a few of those moments where, wow, can't believe my AI system just did that autonomously. But one example that I adapted from a Hugging GPT paper, you say, please generate an image where a girl is reading a book, and it poses the same as a boy in the image, example.jpg, and please describe the new image with your voice. So give an example like this. Today with AI agents, you can kind of decide, first thing I need to do is determine the pose of the boy. Then find the right model, maybe on Hugging Face, to extract the pose. Then next, need to find a post image model to synthesize a picture of a girl as following the instructions. Then use image to text, and then finally use text to speech. And today we actually have agents that I don't want to say they work reliably. They're kind of finicky. They don't always work, but when it works, it's actually pretty amazing. But with agentic loops, sometimes you can recover from earlier failures as well. So I find myself already using research agents for some of my work where I'll want a piece of research, but I don't feel like Googling myself and spend a long time. I should send to the research agent, come back in a few minutes and see what it's come up with. And it sometimes works, sometimes doesn't, right? But that's already a part of my personal workflow. The final design pattern, multi-agent
ChatDev.
collaboration. This is one of those funny things, but it works much better than you might think. But on the left is a screenshot from a paper called
That is spot on. It works much better than what you would think. We cover this in the ChatDev video that I did, where each one of these little guys is its own ChatGPT, GPT 3.5 Turbo, and they code up pretty incredible tools and games and stuff like that, and collaborate to actually problem solve. And it's, when I was doing it, when I was recording it, and I saw what they were doing. But yeah, I was kind of surprised at how well it did, because it was demonstrating to me live some of these things that I read about in papers, but here was actually doing it. GPT 3.5 in general isn't going to be that great of a coder compared to GPT-4 and some of these other models. But when you put a few of them together, you give them separate roles and have them work together to work things out, all of a sudden its abilities go through the roof. And watching that take place live, on my computer using the API to hook into OpenAI, but it was right there. It wasn't a demonstration. It wasn't a paper. It was happening on my computer. They were producing the games and the tools that I was looking for. That was wild.
ChatDev, which is completely open, which is actually open source. Many of you saw the flashy social media announcement of a Devin. ChatDev is actually open source. It runs on my laptop, and what ChatDev does is an example of a multi-agent system where you prompt one LLM to sometimes act like the CEO of a software engineering company, sometimes act like a designer, sometimes act like a product manager, sometimes act like a tester. And this flock of agents that you build by prompting an LLM to tell them, you're now a CEO, you're now a software engineer. They collaborate, have an extended conversation, so that if you tell it, please develop a Go Monkey game, they'll actually spend a few minutes writing code, testing it, iterating, and then generate surprisingly complex programs. Doesn't always work. I've used it. Sometimes it doesn't work. Sometimes it's amazing. But this technology is really getting better. And just one of the design patterns, it turns out that multi-agent debate, where you have different agents, for example, it could be have ChatGPT and Gemini debate each other. That actually results in a better performance as well. So having multiple simulated AI agents work together has a more powerful design pattern as well. So just to summarize, I think these are the patterns I've seen, and I think that if we were to use these patterns, in our work, a lot of us can get a productivity boost quite quickly. And I think that agentic reasoning design patterns are going to be important. This is my last slide. I expect that the set of tasks AI could do will expand dramatically this year because of agentic workflows. And one thing that's actually difficult for people to get used to is when we prompt an LM, we want a response right away. In fact, a decade ago, when I was having discussions at Google on we call it a big box search, we type in a long prompt. One of the reasons I failed to push successfully for that was because when you do a web search, you want a response back in half a second, right? That's just human nature. We like that instant feedback. But for a lot of the agent workflows, I think we'll need to learn to dedicate a task in AI agent and patiently wait minutes, maybe even hours for a response. But just like I've seen a lot of novice managers delegate something to someone and then check in 5 minutes later, right? And that's not productive. I think we need to, it's really difficult. We need to do that with some of our AI agents as well. I heard some laughs. And then one other important trend, fast token generation is important because with these agentic workflows, we're iterating over and over. So the LM is generating tokens for the LM to read. So being able to generate tokens way faster than any human to read is fantastic. And I think that generating more tokens really quickly from even a slightly lower quality LM might give good results compared to slower tokens from a better LM, maybe. It's a little bit controversial because it may let you go around this loop a lot more times, kind of like the results I showed with GPT-3 and an agent architecture on the first slide. And candidly, I'm really looking forward to Claude 5 and Claude 4 and GPT-5 and Gemini 2.0 and all these other wonderful models that many people are building. And part of me feels like if you're looking forward to running your thing on GPT-5 zero shot, you may really get closer to that level of performance on some applications than you might think with agentic reasoning, but on an early model. I think this is an important trend, and honestly, the path to AGI feels like a journey rather than a destination. But I think this type of agent workflows could help us take a small step forward on this very long journey. Thank you.
So yeah, that was it. I really like Andrew Ng. I was mispronouncing his name for so long, but I really like him because he is one of the sort of top tier minds in AI research. So the people see like Ilya Sutskever, Dr. Jim Fan, the people behind, the Transformers, Geoffrey Hinton. I think he's up there with them. Jan LeCun. I think Andrew is up there with them, but he chose, I'm kind of guessing here, but it seems like he chose to focus on teaching more, which is incredible for the rest of us because he has deeplearning.ai as his website. So deeplearning.ai, and you have a lot of free courses here that he teaches him along with many other people from different companies like Hugging Face, Google, et cetera, et cetera. He's obviously very smart, very knowledgeable about AI, also a clear thinker. And I think he does have an ability to explain some of these concepts fairly simply in a way that can make sense to a large audience, which is often not the case. A lot of these people, for all their brilliance, do have a hard time explaining things in a way that's going to make sense to a wider audience. They're very, it's almost like we have to translate it from one level to the next. And I think it is going to be very important for more people to understand this stuff, to have access to this stuff, right? If the sort of general population doesn't really understand some of these concepts, they will be easily manipulated and potentially making the wrong decisions. Some newspaper says we're all going to die because AI, is mad at us or whatever. And some percentage of the people, maybe even the majority, will just simply believe it because the newspaper said so. If more people understand what AI is and the benefits it will bring, as well as the realistic risks that it will bring, I think that would be very beneficial for society because we're not going to have these knee-jerk reactions to the various progress, the various unlocks that we make with AI progress, and instead have more like a rational, calm approach. And these AI agents, like I said, they're not quite here yet in the sense of that most of the things I've tried, it does have pitfalls. You're not going to let it loose on a big, important project and just have it, done when you wake up. It's not 100% accurate. It'll break down. There's tons of issues, but we're making a lot of progress, and we're making a lot of progress fast, not just in one particular area, but on every front. We're improving how fast our hardware is. We're improving how good these models are, how big these models are. We're improving our ability to prompt them to do what we want. And these things that Andrew talked about, right? He calls them design patterns, right? We have reflection, tool use, planning, multi-agent collaboration. And I think he also talked about what to me, I think is a fifth one, although it's part of multi-agent collaboration, but this idea of the larger, smarter sort of quote unquote manager models, calling up these smaller models to complete certain tasks. So they're like summoning a swarm of agents of their own to then go do stuff on its behalf, which also has been, I guess that's part of multi-agent collaboration, but in my mind, it's almost like a separate thing. So there are these design patterns, and there are potentially more that we haven't discovered. And as we get better at doing that, that will improve. And all these things are kind of compounding on top of each other, right? Faster chips means we can do stuff like this faster. We can do it cheaper, right? So there's maybe more use cases, right? If it costs $1,000 to run an agent like this, to complete a task, well, that's one story. If it costs $1 to do the same tasks, if it's that much cheaper, well, the whole game changes because then all of a sudden the amount of like economically viable tasks on which we can unleash these agents on drastically changes, right? A long time ago, the first episode I saw of Rick and Morty was the one with the car battery in the simulated universe, where Rick, the super smart genius, creates a simulated universe, that has conscious beings and worlds and economies that generate energy that he's able to extract into his world. And he creates that for the sole purpose of being his car battery. And the story gets kind of wild from there because that universe creates its own sub-universe and that universe creates its own sub-universe. This isn't a show for everybody, I understand, but it is interesting to think about how complicated a solution to a problem can get if it's inexpensive to run it. So for example, when you run a Google search, it retrieves 10 blue links and you can click on those links plus some ads, whatever. But let's say you have some sort of a multi-agent collaboration thing set up where when you search for something and you're okay with waiting, an hour or two or overnight for it to do its research, kind of what Andrew Ng was talking about at the beginning of the video. Like, what if that indeed creates, let's say, 1,000 different agents, each with its own little subtasks, some of them going to retrieve the data. The others are sort of like the ones that filter knowledge to try to determine if it's accurate or not. Some of them are like the ones that are supposed to like learn everything. They're supposed to read through the text and kind of like summarize it. They're supposed to be the professors of this thing. And each one can kind of create their own sub-agents to act as assistants for them, etc. As you can imagine, this can get pretty complicated, right? But if it's inexpensive enough and effective enough, this could be used for any basic search that you do. Or you can create these agents to be an entire architectural organization of architects and architect apprentices that work out how to build the coolest castle in Minecraft, right? And then they're unleashed in there, and slowly, brick by brick, they erect this massive structure that is cooler and more intricate than any human would have the patience to do. How realistic is it that we're going to see something like that in the next 5 years? Well, we're seeing things like Grok, GROQ, those computer chips specifically for LLM models that are so much faster and cheaper to run for, on LLM models to do inference, to do the outputs that they do. Assuming any rate of progress in this area, we're probably going to see the cost to run these drop precipitously, right? It's going to be extremely inexpensive, right? So a prompt in GPT-4 now, I'm sure it's measured in cents, a tenth of a cent, right? What happens when it's measured in 1/1,000,000th of a cent? And the context windows are massive. And all these design patterns and systems exist. Like we can always copy and paste certain architecture of how these agents fit together. And you can just copy and paste them from somewhere online, add your favorite models, add your descriptions, and then unleash them on whatever tasks that you want done. Off the top of my head, my guess would be we'll have that in 5 years, but I keep getting surprised by how much faster progress is. So what I think is 5 years, I would have to I wouldn't be surprised if it's here, beginning of next year, or maybe it'll be here in a few months. Those things like Devin, the software development agent, are getting scarily good. Anyways, with that said, my name is Wes Roth. Thank you for watching. I had a tooth extracted yesterday because I rapidly started getting a lot of pain, and somebody at the dentist canceled last minute. So they had to do like this, if you can come in 8 a.m. tomorrow, we can fix it for you. And I was like, whatever, I needed to be fixed. It hurt way too much. So I spent the last 24 hours plus basically eating ice cream because you're supposed to only have soft foods. So I ate ice cream and played Factorio. I'll show you what I built in a different video, but that is to say, I'm back. And let me know what you think about the style of video where we do what the YouTubers call react, right? Or we go through a video like this, break it down, discuss it. But I hope you enjoy that, and I will see you very, very soon.